Welcome to Chemistry Impact Video Demonstrations. I'm Jackie, and today I'll be walking you through an RNA purification protocol. The first thing I'd like to explain is what we're actually going to be doing today is two parts. We're going to be showing you how you purify an RNA sample using a denaturing page acrylamide gel electrophoresis, as well as the electroelution process to elute your RNA from the dPAGE. And so the first thing we'd like to show you is what our actual chamber will look like that contains the dPAGE that has your RNA run on it. So the chamber looks something like this. Contains your gel that you have made, which is your dPAGE, your denaturing polyacrylamide gel electrophoresis. And your sample is loaded into wells that are not clearly seen here, but you can tell that there are two of them if you look closely, in which you load your sample of RNA. Your RNA usually contains dye, which you can see at the bottom of the gel as this blue color. And the dye helps us to know where our RNA should be on the gel. This light blue color runs with a length of RNA at approximately 100 nucleotides. So if you have an RNA molecule that is larger than 100 nucleotides, it should be located somewhere above the blue line, which in our case is the RNA that I'll be showing you today at a nucleotide length of 226. The first thing to do in unloading your dPAGE is to remove the clamps and allow the buffer to flow through. You can then remove the glass plate that contains your gel and your RNA sample and move it to a very clean, sterile place that you have prepared for the cutting out of your RNA sample. You can remove the spacers that are located on both sides of the glass plates. And now you have to pop the glass plate that's sitting on top of your gel. To do that, you can take a spatula and very carefully wedge it between the two glasses. Your gel is in between, and so you want to be very careful not to pop it too quickly, in which case you might tear your gel. So you apply slight pressure until you begin to see bubbles forming. And usually in a quick pop, one of the glass plates will come off, as just happened. Now you'll want to be very careful and note which glass plate your gel is attached to. As can be seen here, my gel seems to be sticking to the top glass plate. So I will want to very gently allow the gel to try and come off of that plate. And so I maneuver the glass plate at an angle to try and allow the gel to peel off on itself naturally and fall on the bottom glass. You'll want to be extra careful doing this to ensure that you don't tear the gel. So the slower and the more careful, the better. Now that I know my gel with the location where my RNA is located is already sitting on the back glass, I can move a little more quickly and remove my top glass. This can be put aside now, and we can focus on covering our gel to ensure that it is protected for the next steps. You'll want to take Saran wrap and cover your entire gel. Now, you can pick up the glass plate, flip your gel over so you can remove the final glass plate. In this step, you'll want to take your spatula again and very carefully, as you pick up the glass, try to dislodge the gel from the bottom of your glass plate so that it's sticking to the saran wrap. Then, as before, very carefully begin to peel the glass, ensuring that your gel is sticking to the saran wrap without tearing. Now you'll want to cover this gel, again with saran wrap. Your gel is now removed from the glass plates and is safely encased in saran wrap for the following steps. We can now put the gel aside for a moment to focus on preparation for what we're going to be doing next. In the next step, we will actually be locating where our RNA band is using a UV light, outlining the band of our RNA, and then we're going to be cutting it out and placing it into dialysis tubing so that we can electrolyte the RNA from the gel. To prepare for that, what I have prepared here are 2 beakers, one for washing your fingers as you move through this process, which is very important to avoiding any contamination to your RNA, and a second beaker that contains our dialysis tubing. This dialysis tubing is pre-soaked for 30 minutes in sterile water, nuclease-free water, and I'm also going to rinse the inside of the tubing to ensure that it's clean. To do that, we can take a pipette, prepared autoclave water, and simply open the dialysis tubing and run the water through the tubing. It's good to do this a few times to ensure proper rinsing of the dialysis tubing. Once you've rinsed the tubing, you can use your fingers to syringe out any excess water. In addition to the dialysis tubing, you'll need clips to clip both sides of the tubing, like such. First, we can add one clip to one end and leave this sitting in our water, prepared for our addition of our RNA band and the buffer that will be eluting our RNA in. That is now prepared for our step that we'll be following. Also be sure to rinse your fingers through the process to ensure that you're cleaning your fingers in case of any nuclease contamination. The next step is to locate where your RNA is on your gel. To do this, we use UV light. So you need your gel and also a Sharpie so that you can outline the gel. The next step is to locate where your RNA band is on your gel. You'll need a handheld UV light and a TLC plate. What we do is we place our gel on the TLC plate, and then we hover our UV light over the gel, like such, to try and locate the dark band that is our RNA. We want to work quickly because UV can damage our RNA. So what we do now is we outline using a Sharpie the band of our RNA, and then we'll be able to cut it out for electroelution. Once you've been able to find and locate your RNA band, you can outline it as such, which allows you the ability to now precisely cut out your band of RNA. It's also important to note that while you're hovering over your gel with your RNA with the UV light, you may see other bands. These other bands are dependent upon the sample you may be running. In my case, I'm looking for the largest RNA band size. And so on my gel, what I would notice is a large band on top and a band beneath that. When you outline this band, you want to be very certain that you're as precise as possible in outlining only the band that you desire to cut out, so that you're obtaining at the end only your desired RNA. We can now move to cutting out our band and placing it into the dialysis tubing for electroelution overnight. With our RNA band outlined, we are now ready to cut out the piece of our gel that contains our RNA and place it into the dialysis tubing for electroelution overnight. The first thing you'll want to do is make sure that everything is new or as sterile and clean as possible. You'll need a brand new razor blade, as well as your already prepared dialysis tubing that's been pre-soaked and pre-rinsed with water and clipped on one side, as well as the second clip already rinsed, and tweezers that are already rinsed as well. You can place your gel on a nice hard surface like the glass plates that we were using previously to make it easier to cut more precisely the band that you have outlined from the UV light. With the new razor, you simply try to cut as closely as possible along the line that you made with your Sharpie marker. You can pause here to now prepare your dialysis tubing. Your RNA band will need to be placed in a buffer in which it will be electroeluted. In this case, we're going to be using TE buffer. So what I have prepared is my serological pipette and my TE buffer. This can now be directly placed into your dialysis tubing. Your TE buffer is now located in the dialysis tubing. If you feel at this point the dialysis tubing is too long, you can always take a pair of scissors and trim the dialysis tubing accordingly. Your dialysis tubing is now ready to have the band placed inside of it. This part can get a little tricky, especially when working on your own. So what you'll want to do is try and create an opening or a way for you to easily open the dialysis tubing, as you'll be coming in holding with one hand your RNA band. You can now take your clean tweezers and peel off the layer of saran that is sitting on top of your RNA band. Rinse the tweezers. And now very carefully, from the center, try to peel up your band that contains your RNA. Being as careful as possible to not allow the gel to rip. Try to insert your gel into the dialysis tubing. The gel will very easily stick to the dialysis tubing. And so once you have it positioned in there, very carefully, try to maneuver it down. Once you're able to get the gel into a position where it's not folded upon itself, you can use more TE buffer to allow it to slide down into the dialysis tubing. So to do this, I will add a little more TE buffer to my pipette. And just adding a little bit, wet the gel. Now the gel has fallen to the bottom of the dialysis tubing. You'll want to try and eliminate any air bubbles that may be in your dialysis tubing. And so to do this again, using your fingers as a syringe, try and pull out any air. You can now clip the dialysis tubing on the other end. Try to maneuver the dialysis bag so that your band of RNA lies in the same direction, horizontally, with the dialysis bag. Your RNA is now ready for electroelution overnight. Your RNA band in the dialysis tubing is now ready to be placed in an electroeluting chamber. The electroeluting chamber is usually at 4 degrees and contains your buffer of choice for running overnight. Ensure once again that your band is horizontal like your dialysis tubing. The tubing should be placed in the center, with your bands still lying horizontally. This will electroelute overnight so that your RNA will come out of the band and you'll be able to obtain it in solution form.